Hello everyone, welcome to Management Tools 303. My name is Bobby Hallahan, and I'm a Senior Specialist Solutions Architect here with the Observability team here at AWS. In today's discussion, we'll be talking about turbocharging cost optimization using CloudWatch metrics. But before we get started, I want to take some time to introduce myself. I've been working at AWS since 2015. Before working at the Observability team here, I worked as a technical account manager supporting our enterprise customers in the public sector. One of the roles of a technical account manager is helping our customers with cost optimization. Doing things such as helping make sure that reserved instance and savings plans coverage is highly utilized and we have a high coverage number, helping identify unused and underutilized resources, as well as looking at underutilized workloads or high cost workloads and seeing if there's a better way to make those more cost efficient. So in short, that from that experience, I found that I became very passionate about cost optimization. So in today's discussion, we'll actually start covering a few of those topics. So first, we'll start talking about cost management tools. We'll do a quick summary and review of the existing ones we can find in the console. Then we'll start speaking about metrics and telemetry, specifically about when combining those two, we can drive powerful cost insights. We'll look at different ways we can go about collecting metrics and an example of how we would do that and then combine that with our existing cost data. And then we'll discuss some example use cases on where we could apply this methodology elsewhere. So let's start by kind of covering a quick example of some of the existing cost management tools and how our customers use them. Please take note that this is a 300 level session, and some assumptions will be made that you have seen these tools used or have directly used these tools before. If not, that's okay, as we'll leave links on the slides where they're referenced to where you can find more information. So let's go ahead and start with the very first cost management tool I would suggest to a new customer getting started, which is the AWS Cost Explorer. So let's ask ourselves, what is the AWS Cost Explorer? Firstly, it's a free tool to view your costs based on your usage. The Cost Explorer helps to monitor and optimize our spending within AWS. It has strong filter and grouping options, so we can then filter by service, tag, AWS account, usage type, things like that. And then we can also create Cost Explorer reports based on tag values. In addition to that, the Cost Explorer supports AWS organizations. So if we have an organization with many AWS accounts, we can use the Cost Explorer to view those costs for all member accounts in our org. In addition to that, the Cost Explorer has an API that we can access programmatically, which has even stronger grouping and filtering options. So let's take a look at a few examples of the Cost Explorer in action. So here we can see an example of the Cost Explorer. We have a time range of approximately 2 months and a daily granularity. We're grouping our costs by service, and we can see here our highest cost driving service is the EC2 container service. This is also known as ECS. So this is one way where we can use the Cost Explorer to dive in to see, for a high spending account, what service is driving the highest cost for us. But then we can kind of dig into this and see what specific usage types from that cost. So what's driving costs in the ECS service? That would be the next question we would want to answer. And the good news is with the Cost Explorer, we can do this. So let's take a look. We have here a second screenshot from the Cost Explorer, which shows us the costs filtered for just the ECS container service, and then we group those costs by their associated usage type. So what we can see here is that the highest cost driver for the ECS service is Fargate CPU hours. And then that's followed up by Fargate memory hours. So ECS Fargate is built based off of CPU and memory, and we can see that CPU costs are our main cost driver. Now, this is a really great starting point, and we can see this method used or applied with other services, such as S3, CloudFront, EC2 Other, to be able to see or get that insight to see of a high spend service, what specific usage type is driving that cost. However, for a decision maker to make or for us to be able to give a decision maker an actionable cost saving recommendation, we need a little bit more information than this. So specifically what's missing here is the resource IDs. as well as utilization. So if we think of, we want to ask ourselves that question, okay, maybe we have many ECS Fargate clusters. What cluster is actually driving this cost? Or of this cost or of the CPU bill, how well are we actually utilizing that CPU usage? So without being able to answer those two questions, we can't make a very actionable suggestion on how to cut down on these costs. Of course, you'll notice at the bottom of the slide, we also have a link to a well-architected lab on using and visualizing costs in the Cost Explorer. If you're new to the Cost Explorer, or if you'd like to learn more about it, please feel free to go ahead and check out that link. Okay, so next we have another cost management tool we recommend to our customers, which is the AWS Cost and Usage Report. So the AWS Cost and Usage Report gives us a little bit more granularity and can help us answer that first question of giving us that resource ID breakdown. So we'll ask ourselves again, what is the AWS Cost and Usage Report? So firstly, this is a report that delivers files to our Amazon S3 bucket up to 3 times daily. And this delivers a report of all of the costs in all of our accounts within the organization. The report has line item details, meaning that any billable usage type that is reported for each line item. In addition to that, we have hourly granularity. So for a given hour, for a given usage type, that's how granular we can get our billing to. And then most importantly, it also includes resource IDs. So now we can start looking at our costs from a resource ID and say for this resource ID, or for a given usage type, we can break down the costs by resource IDs. So for a given hour, we can see what was our highest cost driver and what specific resource ID was generating that cost. That alone is an incredibly powerful cost management tool. We'll also see our customers go ahead and take the data we have from the cost and usage report and start visualizing it or building dashboards from it. Those dashboards can be used for chargeback purposes, if we're in a large enterprise, or just from a pure visualization standpoint, or maybe if we have different line of business owners, they want to have deeper insights into what's driving their cost. That's what we'll see there as well. Normally, we'll see customers use something like Amazon QuickSight or Amazon Redshift or other types of partner BI tools to build those visualizations. So in this next slide here, we'll take a look at a common architecture or reference architecture we have for ingesting the cost and usage report and then building those dashboards. So first we'll start with cost and usage report. Once again, that's that detailed line item report with hourly granularity or hourly periods and granularity down to the usage type and resource ID. Once again, this is delivered to an S3 bucket up to 3 times daily. And then from there, we'll have AWS Glue Crawler and AWS Glue Data Catalog catalog that data. And then that will produce a table in Amazon Athena for us. So at this point right here, we can use this Amazon Athena table to start making advanced queries into any type of usage we're looking for. So if we want to get very granular details on a specific service cost, we can use Athena queries to do that. In addition to this, we can start building Athena views. So create views from those Athena queries, and then use those to power data sources or data sets that we'll use in Amazon QuickSight. From there, then we can start actually building our own customized dashboards, and then we also have a few sample dashboards shown on our documentation. So let's take a look at a couple examples of what this end result looks like. So on this screenshot here, we can see that we have some similar fields to what you might see in the Cost Explorer. So you can see cost by account, service, or cost by line item, or usage type. But where the Cost Explorer gets very powerful is that we can also get those resource IDs, and we have that hourly granularity. So we could take something like this basic example and then start building on it and creating a very like an enterprise scale dashboard for us. And then that's what we can take a look at these other two examples here. So we have a well-architected lab on building out enterprise dashboards for QuickSight with the AWS Cost and Usage Report. This is a pretty in-depth lab that goes through walking through setting this up step by step and includes the pre-built dashboards. So once again, if you haven't set this up, or if this is a new topic to you, or anyone that's getting started with cost management, this is a really great tool and can drive a lot of powerful cost insights. And then here's another example of what a detailed dashboard like this can look like. So this answers that first question of if we need to make a actionable cost-saving recommendation, we first need to know, what resource IDs are driving that cost. However, without having the telemetry data on that, we can't still make a decision on, okay, we know it's costing us a lot of money, but we still don't know how well we're using it without actually going directly to the resource or going directly to see the metrics. So being able to have that data in one place for a decision maker or a financial analysis is incredibly powerful. So this is where we come to talking about usage and telemetry. Specifically, where I'd like to start is what do we mean by usage versus what do we mean by telemetry? So in short, when we think usage, we want to think of anything that would show up in the cost and usage report. So any type of usage type, really. Think anything that we were billed for, how much of it we used, thinking 7,500 hours of an M5 XLarge EC2 instance running. That you could consider that as usage. Now, when we think of telemetry, we want to think of plainly metric data. So CPU usage, memory usage, utilization, that is. So, for example, if we think of those 7,500 hours of an M5 XLarge instance running, hour over hour, what was the average CPU utilization during that time? Or what was the max CPU utilization during that time? And once we combine those two data points, this is where we can start answering that question of what we have provisioned, how well are we actually using it? And to help highlight this or demonstrate this example, we also have a tool that's built into the AWS billing console, which is aptly named the Compute Optimizer. So the Compute Optimizer takes this concept and puts it into practice. And what we see here is the Compute Optimizer will take EC2 CPU metric data, and then optionally memory metric data if that instance has the CloudWatch agent installed and is pushing memory metrics into CloudWatch. So using those two metrics, it's able to make a decision to see, is the instance being overused, is it under provisioned, and then it can make a cost savings recommendation if there's a better instance type that's available. So let's take a look at an example of this. So here what we can see is a different screenshot of the Compute Optimizer. In the very first row, we can see we have an instance ID. The finding is that it's over-provisioned. The current instance type is shown as a C5 XLarge, on-demand price of 17 cents an hour. And then this is where the Compute Optimizer gets very helpful for our customers, is that it gives us a recommended instance type, and it's recommending that based on historic metric data. So it's able to go back and look at historically what the CPU data was, and then once again, optionally, if we're producing memory metrics, what those memory metrics were. And then it can make a recommendation based on what a better instance type fit would be for that workload or for that footprint. In this case, it's recommending a T3 large, which has an on-demand price of about a little over 8 cents an hour. So why this is very powerful is that we go from a high level of, okay, we know EC2 instance running hours is driving costs for our AWS account or for our organization. Maybe we can start looking that down to a specific AWS account even. Or then we can go to a usage type. We see that C5 XLarges are costing us a lot of money. But something with the Compute Optimizer, what this allows us to do is see for a given resource, is there a better fit for it? How well are we using it? And then here's a recommendation on how we can be more cost effective. And in this case, we're essentially cutting our on-demand costs in half. So this concept of being able to apply usage and telemetry metrics to our cost and usage data is incredibly powerful, as we can see with this example of just EC2. However, at AWS we have many services, and the Compute Optimizer doesn't cover all of them. So we could start thinking of similar examples like RDS, Amazon Redshift, Elasticsearch, where we have we could take this similar concept and apply it, as well as many other services. So in these next few slides here, we're going to talk about how we would go about applying that methodology to other AWS services to drive more cost savings insights. So specifically, we'll first talk about what do we need if we already have our cost and usage report set up. We already have those visualizations in QuickSight. What else would we need to be able to make those decisions? And obviously what's missing is CloudWatch metrics, and how are we going to go about collecting them? So I guess the first question we want to ask is, what metrics do we want to collect? And then how frequently do we want to go about collecting them? So for starters, we can think of looking at hourly metric periods. This is so for a couple reasons. One, for efficiency. If we have many AWS accounts we're trying to grab metrics from, many regions, many metrics within those accounts, being able to grab hourly data points would result in fewer data points compared to grabbing metrics at a 5-minute or 1-minute intervals. In addition to that, the cost and usage data gives us that hourly granularity. So we want to be able to match that hourly granularity with the metric data hourly granularity. Now, once again, we can collect this daily or more frequently. The reason why I say that is because our cost and usage report data is only updated about 3 times a day. So potentially we don't need our metric data any more. We don't need it faster than that because it doesn't do us any good without being able to combine it with our cost data. Once again, the collection interval is part of that efficiency design. So we want to make sure the metrics we're grabbing were efficient by using those get metric data APIs. Of course, we want to try to collect our metrics from every linked account because every linked account probably is generating some sort of cost. So we want to be able to analyze that. And then, of course, this last question is collecting all metrics or a subset of metrics. And how we want to go about answering this, I guess, is in twofold. One, we have to make sure that our metric that we're collecting is tied to a resource ID, or can be tied to a resource ID that's expressed in the cost and usage report. So like I said, examples before could be RDS instances, or Elasticsearch, or Redshift, where the metrics that are exposed or emitted from the service actually we can match those to a usage type and resource ID in the Cost Explorer. And then the second question we want to answer is that metric or is that resource ID something where we have the ability to downsize it? So an example potentially being if we have like a CloudFront distribution where we pay on data out, we can't necessarily downsize that because we're not controlling the traffic that's coming to us, unless we use WAF to block it. But ideally, we want to think of something like RDS where we can change the instance size, or EC2 where we can change the instance size, or potentially ECS Fargate where we're able to change the number of tasks as well as the task definitions which determine how big those tasks are. So services like that are very good candidates because we can see the metric data, we can correlate it with the resource ID, and then that resource ID is something we have the ability to either right size or something where we have the ability to get rid of it if it's really not being utilized at all. All right. So in this next slide, we'll take a look at what this architecture looks like to start collecting CloudWatch metrics across our many AWS accounts. So we'll start off with an Amazon CloudWatch event. This is something that we can trigger. We can trigger this daily, or once again more often than that. This can go ahead and kick off an AWS ECS Fargate task, or potentially a Lambda function. It's more up to how you prefer to handle that. So the first thing we'll need to do is go to AWS organizations and get a list of AWS accounts. We can do the list accounts. That will give us the list of accounts we need, and then we would then need to go ahead and assume roles in each of the member accounts within our organization. From there, we would want to then, for each account, and then for each region in each account, we would want to go to the Amazon CloudWatch API and select Get Metric Data APIs and call all of that. So once we have the metric data for each region and in each account that we want to collect metrics from, we can then have that write those metrics to a centralized location in S3. So in the next couple slides here, we'll walk through some example code of some of these tasks that we would need to perform. So firstly, what we would need to do is get a list of regions that we need to collect metrics from. So this can be something where we statically populate it. We could use like the describe, there's an EC2 APIs we can do this for, but in this example, what we'll go ahead and do is we'll use systems manager parameter store to grab our list of regions. So we'll initialize an AWS systems manager client. We'll create a region list. From there, we'll use the get parameters by path. So this is what's actually important here is we have a path parameter that shows AWS service global infrastructure regions. So this is a systems manager parameter that's published to every customer, and any customer can reference, and it gives them a list of every available region within AWS. And then from there, we'll go ahead and just grab the values. So that would be like US East 1, US East 2, and then we just add that to our list. So far, fairly straightforward. The next task that we'll have to do is assuming roles across our organization. So we have a list of regions, and then now we also need a list of AWS accounts that we need to assume roles in. So for this, well, of course, like we said, we'll use AWS organizations. So we'll create an organizations client, and then we'll paginate over the list accounts API. So if we have many AWS accounts in our organization, we'll probably need to page through those responses. If we've ever listed an S3 bucket programmatically, where we get a request a list of something, we don't get the full list back, and we could get something like a next token, and we'll use that token in our next request to get the next batch of results. So that's what these paginators in Python allow us to do. And then from here, so for each page of results we get back for each account in those pages, we'll go ahead and assume an IAM role in those accounts. So in this case, what we can see is the IAM role, ARN, which is our account ID, and then we have a role named metric collector. So this is an IAM role that would exist in all of our member accounts ahead of time. And then we have a role session name, as well as a role duration of, in this case, 1 hour. The next API we would want to run here is then list metrics. So for each region, each account, we want to be able to list those metrics that we want to collect. In this case, we're hitting the CloudWatch list metrics API. And then in the example code here, what we're doing is actually collecting every metric. However, what you can see in those comments ahead and the lines above, where we use CloudWatch paginator.paginate, and then we're only listing metrics for a given namespace. So this goes back to that initial question we asked of what metrics do we want to collect, and this is where we make that decision essentially of do we want to collect metrics for a specific namespace, or are there specific namespaces and dimensions where we want to be able to collect our metrics from, and using that's how we get whatever metrics we need. And then from there, once we have that list of metrics, we can go to actually fetching them. And then this would be that get metric data API. So for every metric list, for every metric in that metric list we get back, we want to create a metric data query. So this is how that get metric data API works, where we have a list of these metric data queries. That is a combination of the namespace, the metric dimension, the metric name, as well as the period. So in this case, our periods are hourly. And then, of course, our statistic here is average. Our statistics can be, we could use, min, max, a percentile if we'd like to. However, what I'd like to, I guess the purpose of these examples are to show this is potentially how we could go about doing it, but there may be more sophisticated ways to, dynamically plug in what statistic we would like to grab. And then from there, we just paginate over the get metric data responses. So at this point, we can assume that we've had, now we have our cost and usage data in QuickSight for creating dashboards. We have the availability to those resource IDs. And in addition to that, now we have the CloudWatch metrics as well for those specific resource IDs. So let's take a look at what this looks like in practice of combining those. So on this first slide, we can see that this is similar architecture to what we have earlier, where we have our cost and usage report delivering to an S3 bucket. That S3 bucket goes to Glue. AWS Glue is used to create our Athena table. Athena is used to create some views, which are then used as data sets in QuickSight. However, now what we can do is, what you'll see, this new feature is that AWS Fargate metric collector. So this could be, once again, that it could be a Fargate task or a Lambda function, and all its job is to do is once a day or several times a day, assume roles in the accounts, collect metrics for what we'd like to, and then write them to S3. The rest of the process from Glue to Athena, that methodology is pretty much the same. So let's take a look at an example dashboard of where we have combined metric data as well as with our cost and usage data. So here we can see a dashboard where we've taken our costs from the ECS service and we're diving into those costs. So in this case, we can see that we were able to identify of the ECS clusters we have, which one's costing us the most money. And in this case, maybe we've identified that cluster and we've created a dashboard to represent the costs of that cluster. So in this case, we can see the memory per task is set to 2 gigabytes, CPU set to 1. We can see that the majority of our cost driving, of course, is CPU hours. And then from this visual, we can see there's a few things that are generated from metric data and a few things that are generated from cost and usage data. However, where I'd like to draw your attention to is the bottom two visualizations. Here we can see memory cost versus memory utilization, as well as CPU cost versus CPU utilization. So on memory cost, we can see that orange was represented by the orange bars is our hourly unblended cost. So this is how much that memory usage is costing us hourly. And then if you look towards the bottom of that, you'll see a blue line, which its values are represented on the right y-axis, and percentages, which is percent utilization of that memory. So of the memory, how much it's costing us, this is how much we're actually utilizing of it, which in this case is around 10%, which honestly isn't that great. The picture in this case also looks kind of worse for CPU utilization, where we can barely see that blue line for the CPU cost compared to utilization. And we can see our CPU utilization is less than, what looks to be less than 1%, which isn't that great. However, this helps us get to that answer that we're looking for to a decision maker to make a cost savings recommendation. Because now we were, let's say, able to identify what ECS cluster is driving the highest cost for us using the cost and usage report. And then by using a combination of metrics, telemetry metrics from the ECS service, as well as details from the cost and usage report, we're able to dive in and see that in this case, we probably have too many ECS tasks running. And our task definition sizing is definitely too big. For how much CPU we have provisioned, we're not nearly using as much as we're provisioning. Same goes with memory. So some of the suggestions here would probably be, let's resize those tasks so they consume less CPU and use less memory, as well as provision fewer of the tasks. In this case, we have about 3 or 4 tasks running. Maybe we don't need that many. So let's take a look at an updated example of this slide after we made those changes. So in this case, the changes we've made are we dramatically lowered the number of ECS tasks that we're running. And then we also changed the task definition. So our memory, we cut that in half from 2 gigabytes down to 1. And then the CPU per task, we took that from 1 vCPU down to a quarter vCPU. Now, once again, I'll direct your attention to the bottom two visualizations on this slide where we can see that our cost for memory as well as CPU has dropped dramatically. And then in addition to that, our efficiency or our utilization has increased. So our memory usage or our memory, how much we're actually utilizing is closer to 50% now. And then our CPU utilization is up to from under like 1% up to like 10%, which is a pretty good gain. So not only have we cut costs, but what we're spending on, we're actually using that more efficiently as well. And I think this is where customers can drive a lot of value, and not just for ECS, but we can look at a few other use cases as well. So specifically, one of them could be charging and allocating costs for multi-tenant infrastructure. We could look at combining resource telemetry with business metrics. We can look at Amazon Redshift utilization and sizing. We could look at Kinesis data shard optimization. And we can also look at Amazon Elastic Container Service ECS Fargate task sizing, which was the example we just demonstrated. So with that, I'd like to see that our customers could go ahead and start using this same methodology of being able to combine metric data with cost data, not just for EC2, not just for ECS, but many other services. And hopefully we'll see this methodology used more so in the future. With that, I'd like to thank you for your time today. And if you have any questions or would like to learn more about this topic, feel free to reach out to me. My handle is rfhall@amazon.com. And if you did enjoy this session, please feel free to fill out the session survey. Thank you.